Okay, so I ran out of time on that last video and I left off talking about boiling. And of course, you know the process of boiling, but you've probably not heard it defined as this: the temperature at which the vapor pressure of the liquid equals the external pressure on the liquid. So the vapor pressure is equal to the external pressure. And so what happens is boiling point can be affected, therefore, by the pressure that is in the atmosphere around it. So, if there is a lower pressure, that means there is a lower boiling point. Water boils very quickly on the mountaintop, but the temperature reached is lower than 100 degrees Celsius. Um, an increase in pressure would raise the boiling point of water. Water will boil at a higher temperature above 100 degrees Celsius. So if you look at this image, and this is from your text, so you could look at it there as well, this is at sea level. Okay, atmospheric pressure is 101.3 kPa, that's standard pressure, and it's at 70 degrees Celsius. Um, that is greater than the vapor pressure, then bubbles of vapor cannot form in the water and it does not boil. Sea level at the boiling point of 100 degrees Celsius is when the vapor pressure is equal to the atmospheric pressure, and so then the bubbles form and it boils. But if you were to go atop Mount Everest, higher altitude, less pressure, then the water will boil at a lower temperature, it's like 70 degrees Celsius. So, normal boiling point. We are adding this term normal in front of it to indicate that there is a special name for the boiling point that occurs at a pressure of 101.3 kPa, which is kilopascals. But you just need to know for right now that that is a unit of measure for pressure. And so that's standard pressure. I don't remember if you, perhaps you remember STP, that's standard temperature and pressure. And we always talked about standard temperature and pressure being equal to 22.4 liters. 1 mole is equal to that much. Well, here's standard pressure now that we're talking about. So we can look at vapor pressure and boiling and temperature. And this is a curve of 4 different substances here. Um, and the 101.3 kPa line indicates the boiling point of that substance at standard pressure. So where these cross, the boiling point at standard pressure is at 101.3 kPa. So the first question is, what is the boiling point of chloroform at 101.3 kPa? This is a simple one. You follow the line for chloroform, you go up to 101.3 kPa, and you read down to the temperature, and it is 60 degrees Celsius. What is the vapor pressure of ethanol? At 40 degrees Celsius. So here's 40 degrees. You go up to the ethanol line and across to the vapor pressure. And over here, it is 20 kPa. And then the last question, what would atmospheric pressure need to be for ethanoic acid to boil at 80 degrees Celsius? Well, if we have 80 degrees Celsius, boiling is when the atmospheric pressure is equal to the vapor pressure. So if we have 80 degrees Celsius right here, then for ethanoic acid, that is at 30 kPa. So in order for it to boil, the vapor pressure must equal the atmospheric pressure. So your answer is going to be 30 kPa. Melting. Now, we just did a lab that involved the melting and freezing. And for melting, heat is applied. And when the heat is applied, there is an increase in kinetic energy, so the particles vibrate. And simply the organization of the solid breaks down. Solids are highly organized, they're in fixed positions. And so what will happen is the attractions that hold the particles are overcome, and then the solid will melt. So the melting point term is the temperature at which a solid melts into a liquid. And we've been talking about that. The freezing point and the melting point are the same temperature. And at that temperature, both liquid and solid are in equilibrium. They're both present. And that is why you have that leveled off area in your graphs for your